All right, guys. So today we're going over 4.1 triangles and angles. You should have your worksheets in front of you. Then classify the notes. All right. So first thing we're going to do, we're going to start off by classifying triangles. And there's two ways we can classify triangles. One, by their angles, and two, by their sides. We're going to start off with the angles. There's three types we can do it. One is equilateral, in which three congruent sides, equilateral, equal sides, equilateral. And again, we represent those by tick marks. You always do that. Equal three congruent sides. Isosceles triangles, two congruent sides. Now I'm going to add something that says at least two congruent sides. So what that does mean is that, yes, two sides are congruent, but that also means that an equilateral triangle is actually technically isosceles as well. So isosceles means at least two congruent sides, equilateral one. And please try to learn how to spell isosceles. It is one of those misspelled words, and you do get some funny stories about it. And then the third type is scalene. Scalene means none of the sides are congruent. So none of the sides will be congruent. And there's also a relationship between sides and angles, guys. And real quickly is if the sides are the same, the angle's opposite of them the same. We'll get to what opposite means later. All right. Now, by angles, all right, so that was by sides. By angles here, we got acute triangles. So three acute angles. So all my angles are acute. So I give you an example here of triangle ABC. And we see that the three angles, CAB, ABC, and CCA, are all acute angles. And these are the measure actually of these angles. So we see they're all acute. They're all less than 90. Therefore, acute. All acute angles, acute triangle. Equiangular triangles, all three angles are congruent. So they're all the same. So if we look again as our markings, we'd have our little arc marks, and they would all be singles. And you can see they're all the same. So they are congruent. This is actually a special acute triangle because what we'll learn is that all these angles are going to be acute and they're all the same. So that's what makes it equiangular. And then the other two we have are right triangles, which have one right angle, and obtuse triangles, which have one obtuse angle. And we'll get to a reason why they can only have one of those each. Some of you guys may already know this, but we'll get to that in a minute. Now, parts of a triangle, all right? Parts of the triangle, they're made up of vertices and sides, okay? The vertices, as we learned before, are vertexes, right? They're represented by capital letters. Those are points, and they're the point where two sides meet. Point where two sides meet. Any two sides that share a common vertex are called adjacent sides. So here in this diagram, we see that BA and CA are adjacent sides because they share the vertex A. They both share that A, so they are adjacent sides. The side that is not touching A would be called the opposite side, or the side opposite of angle A. And we can do that for any C. So it doesn't matter if we're doing it for C or for B. Whatever side we're talking about, there's always a side opposite. And it's the side that doesn't touch that angle or that vertices. And I know on your sheets, guys, definitions, you have triangle, guys. You should know it by now, but a triangle is a polygon with three sides. We're just going to pretty much get that out of the way. All right, so we have vertices, A, B, C, and then we have our sides, each side, CB, BA, AC, and then we can talk about adjacent and opposite. And it doesn't, it just depends on your perspective how you want to label those. All right. So for right triangles, again, are made up of sides and vertices the same. However, the two sides that make up the right angle are called legs, and the side opposite the right angle is called the hypotenuse, another very misspelled word, hypotenuse, hypotenuse, if you basically phonetically say it, hypotenuse, hypotenuse, right? So made up of two legs, which form the right angle, so they're perpendicular to each other. And the side opposite the right angle is the hypotenuse. And it's always like that, no matter what type of right triangle we're dealing with. And then we have isosceles triangles. Now, isosceles triangles, they also have legs too. The two sides that are congruent in isosceles are what we label as the legs. So you see here we have our two sides. They have the tick marks. They are congruent. They're called legs. And the side that is not a leg is called the base. All right? So dealing with this, we have isosceles. Now, if they happen to be equilateral, then any two sides can be your legs and the third side can be the base. It doesn't matter. But in most isosceles triangles, two sides will be congruent, and the third side is the base. Just for future reference, the point where the vertex that is shared by the legs is called the pinnacle or the apex a lot of times. Just be aware of that. So we're going to get an example here and say, okay, identify the parts of the isosceles triangle. Explain why triangle ABC is an isosceles right triangle. And what you see here is two things. You got to show it's isosceles, and you got to show it's a right triangle. We know it's isosceles just because if you look at it, AC and BC are both 5 feet. Since they are equal, they are congruent, which makes it isosceles. And if you look at it, AC and BC are perpendicular to each other because they form the right angle at angle C. Therefore, it is a right angle. So therefore, by definition, it is a right isosceles triangle. And here's the explanation. Diagram C is right angle. By definition, it's a right triangle. A, B, AC, BC are both 5. Therefore, they're congruent. So it's isosceles. All right. Now, given this, identify the legs and the hypotenuse of ABC, triangle ABC. Which side is the base of the triangle? So for legs, remember, our legs are sides that are congruent. So AC and BC are our legs, and my hypotenuse is my base, because it's the third side. All right. Now, I have this triangle here, ABC, and what you'll see is that I've extended the sides. And the reason I extend the sides is because what that does, it helps create what we call exterior angles. Let's start with the interior. The smiley faces on this are going to represent interior angles, and the hearts will represent the exterior. So our interior angles here, angles A, B, and C, those are interior angles because they're on the inside of the triangle. My exterior angles, and the reason why I extended the sides, it's not the whole angle outside of it, guys, because remember, angles can't be greater than 180. If you did all this, that would be like, if the smiley face was, like 50 degrees, that would mean everything outside of it is 310. That doesn't work. You can't have an angle more than 310 for more than 180. Why would we have an angle at 310? So the reason we draw the line out is because the exterior angle will always be a linear pair to the interior angle, and we'll get into more of that later. But we see here are my hearts. Those are my exterior. Now, one thing about that is that you can draw or extend the sides in either direction. So we see how we did it in this case, and it makes this pendulum this way. We can always draw it the other way, where we have our lines going like this in green, and therefore there, and there. Those would be my exterior angles at that point. And you'll see that they are actually vertical to the hearts as well. So it's not like the values changing, they're still going to be safe, and they're supplementary to our inside lines. So I'm going to erase those real quick just to keep it a little bit cleaner. All right, I'll show you a comment with it. All right, so triangle sum theorem. This all leads up to a certain thing. Triangle sum theorem. Some of you guys may have seen this before. The sum of the interior angles of a triangle are always 180. They always add up to 180. Doesn't matter how big, small, obtuse, right, whatever. They always have to add up to 180. And since they add up to 180, we know certain things about it. So we asked why you could not have more than one angle in a right triangle that's right, or more than one angle in an obtuse triangle that's more than 90 degrees, is because if you actually had two of them, it wouldn't make a triangle. 90 and 90 would be 180. What are your other angles? 0? We don't have 0-degree angles. Or if you did it something like 100 and 100, well, 200-degree angles is 200. You can't have a negative 20-degree angle. It doesn't work. So we wouldn't make a triangle at that point. You make two straight lines or parallel lines, things like that. That wouldn't make triangles. That just makes parallel lines or lines going away. So they have to add up to 180, and that holds true no matter what. So keep that in mind. It makes a lot of things simpler. All right. The next one is the exterior angle theorem. And the exterior angle theorem basically says that the exterior angle to one angle of a triangle is equal to the sum of the two non-adjacent interior angles. So we see here we have angle 1, and it is equal to the sum of A plus B. And we can actually prove this if we do this through, if we just use our substitution and transitive properties. So I'm going to write this over here on the side, but I'm going to show you why this works. So if we call this angle down here C, and we have angle C, A, B, C, and 1, we know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 based on the triangle sum theorem. We also know that the measure of angle C plus the measure of angle 1 equals 180 linear pair postulate. Therefore, look, they both equal 180. So we can say that the measure of A plus the measure of B plus the measure of C equals the measure of A plus the measure of angle 1, oh, not A, sorry, C and 1. And what do we notice? That they both have the measure of angle C. So if we subtract C out, we get measure of angle A plus the measure of angle B equals the measure of angle 1, which is exactly what the triangle sum tells us. So we've actually proven that this theorem holds true. It's pretty neat. All right, so here we go. Finding the exterior angle. So we got to find the angle, find the measure of x. All right, and we're going to find the angle measures too. All right, so given this, we want to solve. So we see that we have an exterior angle and we have our two non-adjacent interior angles. We know that the exterior angle is equal to the sum of the two non-adjacent. So my equation that I produce is x plus 65 equals 2x plus 10. And we'll just solve for x. So we're going to subtract x from both sides, and then we're going to add 10 and subtract 10 from both sides. And we end up with x is 55. So we see that this angle, x is 55, which means our angle down here is 55. And that means our exterior angle, if you plug it in, would equal 120. And you can either plug it into 2 times 55, 110 plus 10 is 120, or add up 55 and 65. That will give you 120 as well. All right, corollary to the triangle sum theorem. Now, corollary just means like special case. It means if this happens or this occurs, this special thing does happen. It means that. Special case. So what this is telling us is that if we have a right triangle, so only for right triangles, doesn't work with acute, doesn't work with obtuse, doesn't work with equilateral, only works with right triangles. And what it says is if we have a right triangle, then the two non-right angles are complementary. And it makes sense if you think about it. In a right triangle, that angle is 90. We know that all three angles add up to 180. So therefore, A, B, and 90 equal 180. A and B have to equal 90. So if you wanted to prove it, measure of angle A plus measure of angle B plus 90 degrees equals 180. Therefore, measure of angle A plus measure of angle B equals 90 degrees, which is what we were looking for. So we get an example here. I give you this and say, all right, find me the value of x. We know angle C is going to be a right triangle. We're going to find x. So to solve it, we've set up our equation. We know that these two angles, since they are the non-right angles in the right triangle, they have to be complementary. So x plus 2x equals 90. Combine like terms. 3x equals 90. So x equals 30. Which means angle A here is 30 degrees. And angle B here has to be 60 degrees. All right. So what I want you to do is finish working the rest of this worksheet. We will post the answer key and we'll see you later.